All right, for example 2, we're going to find the volume of the solid whose base is bounded by the circle, and that circle obviously has a radius of 2. We've talked about that. And we're going to have semicircular cross sections, and they're going to be perpendicular to the x-axis. So getting a picture of that, we're going to be from -2 to 2. Again, remember this is my r squared, so that would mean my r, or my radius, is 2. And then we're going to go from -2 to 2 on the y-axis as well. Okay, so what we have are semicircles coming up being perpendicular to the y-axis. So there's my perpendicular, and then we've got these semicircles that are kind of coming straight up out of there. And then maybe we've got one here that's kind of coming straight up. All right, so we have to find the area of the semicircle, and just as a reminder, the area of a circle is pi r squared. So the area of a semicircle is going to be pi r squared divided by 2. So what is this radius going to be? Well, that's a y value, and I can solve for y here. Remember, we have x squared plus y squared equals 4. Subtract the x squared. I'd get y squared equals 4 minus x squared, and then square root that, and I get y equals the square root of 4 minus x squared. It is plus or minus, but the positive one is this right here, and the negative one is going to be the bottom down below. All right, so that's going to be our y value. That's going to be, this is a y, right? A y distance right here. So that's going to be equal to this. So we're going to have the integral of a pi r squared divided by 2. And I'm going to pull that pi out. And my radius is this right here in black, is this function. So I'm going to have square root of 4 minus x squared. And I'm going to square that. And then I'm going to divide by 2. So this is my pi r squared divided by 2. And then don't forget your dx. Our bounds are going to be from a -2 to 2. All right, there's number 2. See, they're definitely not taking as long now. All right, now for this next one, what we have is a different curve for the first time. We actually have the curve y equals x, which is this curve right here. And then we also have the x-axis, which is this right here. And then we have the line x equals 5, which is right here. And the cross sections here are going to be squares. All right, so our squares are going to be coming up like this. I'm not really the best artist in the world, but our squares are coming up like that. And so what's our area of our square going to be? Well, this length right here, get a different color. This length right here is the same as this, and that's going to just be the value of x. And you can think of it as you want, as being x minus my lower curve, which is 0, or you can just think this is the height of x. And then of course, if it's a square, we know this will be x as well. So the area of our cross section is just going to be x times x, which is x squared. And now we're going from a 0 to a 5. And that would give us our answer. And certainly you could pick up your calculator and get an actual answer for that. All right, next one, number 4, says find the volume of a solid whose base is the region inside the circle we're used to. That's a radius of 2. But this time our cross sections are going to be equilateral triangles. Now folks, before we start this problem, I am going to give you a bit of a reminder from geometry that if I have a 30, 60, 90 triangle, and I have that this is a 2x, you learn this in geometry that this would be half of the hypotenuse, or x, and then this would be an x root 3. So for example, if I had something like 6, this side here would be 3, then I would rewrite the number 3, and then I would put on a root 3. Another example would be if I had an 8, this would be a 4, and this would be a 4 root 3. And that only works when you have 30 degrees and a 60 degrees here. We call that a 30, 60, 90 triangle. All right, so that's my reminder. All right, so now let's go ahead and let's draw this picture. So again, I've got a circle from -2 to 2, -2 to 2. Missed it. All I'm going to do is just fix my 2 here. And now I've got equilateral triangles coming off. So I'm going to do my best to draw that. I bet some of you have some really awesome pictures. I don't know, a triangle kind of coming up like that. So you got a triangle coming straight up like that. All right, so for this triangle right here, let's go ahead and let's get our base and a different color here so you can see that, but our base is this. Our base is that. And we should have this memorized by now, but this section right here is a square root of 4 minus x squared from this. And this section right here is a negative square root of 4 minus x squared. So this whole distance, you can either think about doing this minus a negative square root of 4 minus x squared, or you can just think about the fact that you basically have 2 of these black things. You've got one here and you've got one here. So this would be 2 square root of 4 minus x squared. All right, now let's go back to my reminder. And my reminder was that if we have an equilateral triangle, I can say that this is a 2 square root of 4 minus x squared. But when I break this down and I get a 30, 60, 90 triangle, right, I'm cutting this thing in half, this would actually give me a square root of 4 minus x squared, and this would be the 2 4 minus x squared. Do you see what I did there? I basically took this and then I wrote it here and then I cut it in half because we're just taking half of that triangle. And then I just need to find my height, and that's going to be this thing right here. Well, we know from our special right triangles that we rewrite this thing. It's going to be a square root of 4 minus x squared, but then we put on the root 3. So when I'm finding the area of a triangle, my area is 1/2 base times height. So my base is going to be this orange thing right here. That's going to be my base. And then my height is going to be this purple thing right here, which is the same thing as that, right? You think about how I cut that. So that's going to be my purple. So my integral here is going to be the integral from -2 to 2. Remember, we're looking at our x values here, -2 to 2. And we're going to have 1/2. The base of the triangle is this. That's going to be a 2 root 4 minus x squared. And then I'm going to times that by my height, which is my purple thing right here. And that's going to be the square root of 4 minus x squared, and then root 3. And then don't forget your dx. And of course, we can throw this into our calculator and get our answer. All right, example 5 is to draw a blade of grass. Here I am. That is it. I did a really nice job, maybe a little bit of dimension. Oh yeah, maybe a shadow. Nailed it. Thanks for watching. We've got a few more examples in the next video.